Good afternoon or good morning, fifth graders. Welcome to lesson 5.5 and 5.6. We've combined these two lessons just because 5.5 is actually going to be the first two videos and 5.6 will be the second two videos. So pretty simple. And today we're going to ask you two questions. One, how do fractions values change? And then the second, what is the difference between a fraction and a mixed number? So give me a second and I will type those up. And that's something I want to make sure that you are writing down. Alright, when we look at lesson 5.5, we're going to look at the relative value of a fraction. Which means if I give you this right here, okay, and I color it in, or try to color in, that's going to be 1 of 1. Now, the thing is, that value is going to change because if I go like this, and let's pretend that's an actual nice looking rectangle, now that's no longer 1 out of 1, that's 1 out of 3. And I can continue as I go through, and now that's no longer 1 out of 3, that's going to be 1 out of 5. But if you notice, and let's pretend that I did a good job of drawing the same one. I probably should use the graph paper for this one, but they're all the same. So a lot of it is going to see, a lot of when we look at this value, it's going to depend on the size of the whole. So when we talk about a change in a fraction's value, the size of the whole, as the size of the whole changes, so as the size of the whole changes, the size of the fraction changes. And perhaps fraction is not quite the right word, but it's the top number. As the size of the whole changes, so it's still 1, it's still 1, it's still 1, but now this is the whole thing. This is now 1 of 3, this is 1 of 5, even though it's the same size. I mean, I'd look at it much simpler if I had a triangle, okay, but then I have two triangles, or I have four triangles. This triangle, even though it's the same as here, when you look at it right here, it's less important just because there's more triangles. So it's a relative thing. Now, why is this important and how is this important? Well, let's look at the problem with, I believe it's Ben and Gabby, and they're talking about cherries. So give me a second to type it up, and you guys cut it out and paste it. Ben and Gabby have 80 cherries. They need 50 cherries to make a pie, and they would also like a snack. Ben wants to eat half of the 80 cherries, and Gabby wants to eat 1/4 of them. Will that leave enough cherries for the pie? Why or why not? Now, when we look at this, we have to think about, all right, how many are they going to eat? So if they have 80 cherries, okay, and that's where we're going to start. They have 80 cherries. Now, Ben wants to eat half of those 80 cherries. So we have to figure out, what is half of 80? Well, half of 80, we know half of 8 is 4. 80 we're just adding a 0 to. So Ben wants to eat 40 cherries. And then Gabby wants to eat 1/4 of that. So again, we're going to take the 80 and we divide that by 4. Well, we're going to break it into 4 equal sections. 1, 2, 3, 4. Well, if I look at 8 and break that into 4 sections, 8 divided by 4 is going to be 2, 2, 2, 2. And we're just going to add the 0 because 20, 40, 60, 80. So Gabby wants to eat 20. So if Gabby eats if Ben wants to eat 40, and Gabby wants to eat 20, they're going to eat 60 total. So if they eat 60 cherries, are they going to have enough cherries to make the pie? Well, the question is, how many cherries did they need to make the pie? Well, let's look right here. They need 50 cherries to make a pie. If they're eating 60 of them, 80 minus 60 is going to give us 20. Are they going to have enough? No, because they're eating way too many cherries. So how do we solve that problem? How do we move, how can we get it so that they can make a pie and they can have a snack? And I think that's the important thing. So video 2 is going to start with the next part of the story problem.